look at rotations. You know, rotations are turning a shape. With rotations, you need a center of rotation to turn around. We're going to turn ours around the origin. Which is where the x-axis and y-axis meet. It's, you know, 0, 0. All right, so we're going to look at rotation. I'm going to do some examples, and we're going to see if it preserves orientation and isometry. So we're going to move to this Desmos, and we are going to first do a transformation. We're going to pick this rotation. Okay, we're going to pick right here the origin as our center, and we're going to move it 90 degrees. We're going to apply. Ugh, it's a little bit tall. Can I change that? Let's see. So it moved way, yeah, there we go. I'll just move them a little bit. Okay, so if we look, I'm going to move this just slightly so it's right on dots. Okay, so if we look, we still have that same look about it. We're just going to add these points in. I know that this point, if I look, it's, you know, that smaller angle right there. So I can tell that this is B prime. I'm just going to put that in. Oop, let's do capital. B prime. And then we're going to look, this one up here is obviously at the very top right there. That is going to be my A prime. And then we'll look over here at this one, which looks like it's almost 90 degrees. And we're going to call this point, because I can see that it is right here, we're going to call this C prime. So that is where we're going for this. So I am going to show you that this is 90 degrees. If we were to draw a segment from here to here, and from here to here, we can see that that's a 90-degree angle. But if we look, so I'm going to delete those just so we can look at this better. C to B is the same length. A to C is the same length. A to B is the same length. These are all the same lengths. Same angles. And if we look, the same orientation. A, B, C, A, B, C. So we can look right here. And we can say, yes, it does preserve orientation. And yes, it is isometry. We're going to look at counterclockwise is going to be what we're going to look at first. And counterclockwise is always a positive rotation. And I can't really show counterclockwise other than to go, we did move, this was a transformation of 90 degrees. So from here to here, that was a clockwise, a counterclockwise rotation, which is positive. So my clockwise rotation is going to be with negative. That's a negative rotation. And we're going to talk about some things with rotation notation. We do rotation is always a capital, and we're going to look at just a couple. We're going to look at 90, we're going to look at 180, and we're going to look at 270. And we're going to look at just, and this is going to be all clockwise at first, and then we'll look at counterclockwise. So this is clockwise rotation, and so that's going to be positive. So I like to put all of those right there. When we go from 90 degrees and we have X comma Y, and we do that 90-degree rotation, we are going to get X negative Y. So let's just double check right here with the points that we have before. If I was to label B, if I was going to go over 1, 2, 3, 4, up 1, so I can just, I don't know if it'll let me draw it in here. Maybe I can change the label of this. That is 4, comma 1. If I follow that rule that I've set right here, where it's x comma negative y, for b, we should have, oh, I'm sorry, it's negative yx. I was incorrect. It is negative yx, which makes so much more sense. So if I look, I get negative 1 up 1, 2, 3, 4. So this right here is negative 1, comma 4. So I did switch from 4, 1 to negative 1, 4. Switched it and changed that sign. If we're going from x 180, we go from x comma y to negative x negative y. And when we do 270, we go from x comma y to y comma negative x. Okay, so if we're going to look at this with clockwise, which is negative, it's just, I just need to switch things around and it's actually less to memorize. So this is the same thing as rotating negative 270 is the same as 90. Rotating 180 versus negative 180 is the same thing. And then instead of 270, we would talk about rotating for negative 90. I have another nice way of doing this. This rule's right here, kind of going over that 90 and negative 270, 180, 180, 270, 90, and 360, it just stays the same. So let's go here and do one more example. Let's do negative 90 or 270 here. So I'm just gonna delete this, make this all go away. Okay, so I'm going to do another transformation, but this time I am going to do a rotation about the origin for this, but instead of 90, I'm going to put 270. Okay, now we've got to label them so we can just, see each of these points. This one right here, if we see it's coming around, that is B. So this is my B prime. And let's just say what point it is. It is at 1, 2, 3, 4. 1, 2, 3, 4. So it's at positive 1, negative 4. Okay, so if we look here at my rules for 270 says I flip them and I change the sign of x. So I have flipped them and I have changed the x sign right there. Now, if we were to move this whole thing, let's say we move it here, and so we've got to change my label. That's 4, negative 1. Negative 4, positive 1. We want to see where our new point will be here. So if we look, the formula again for doing 270 is y negative x. So we'd have 1, positive 4. So this actually up here changes to 1, positive 4. So remember, it's when that negative is, it doesn't make it negative, it changes the sign. So those are just a couple of examples of rotation and rotation rules.